Welcome you all. In this video, I am going to explain about the simulation of DC-DC converter in boost mode with open loop control. DC-DC converter is a powertronic device which converts power from DC to DC. Either it can be boost or it can be buck. So this is the circuit we are going to model. So here I have considered a simple DC-DC converter circuit topology. A DC voltage of 100 volt is converted into AC first, then a 3-winding transformer, 2 diodes and a capacitor. With the configuration of these elements, we can boost up the voltage by 1.5 times, and R is the load of this circuit. So let us see how to simulate this in Matlab. So in the Matlab window, click Simulink library, then click this icon to create a new model. So a new model page will open like this. So first we need powertronic switches. So for that, in the library, go to Simscape, Sim Power Systems, Specialized Technology and Power Electronics. So here depends upon your application, you can use IGBT or you can use MOSFET. So here in this video I am going to use ideal switch. So Control R to rotate. So I am renaming it as switch 1, S1. So then Control left click drag to make another copy, S2, S3, S4. So connect these switches. Then we need a DC source. So for that, Sim Power Systems, Specialized Technology, Electrical Sources, DC voltage source. Drag and drop it. So connect at the input terminals of our converter. So here 100 volt is the default. I am using the same. Then we need a transformer. So for that, go to Simscape, Sim Power Systems, Elements, Specialized Technology, Elements. In that we can get linear transformer. Drag and drop it in the model page. Connect at the output of the converter, output terminals of the converter. So then click this. So here nominal power I am taking 50 VA and the frequency of the transformer I am taking it as 50 Hertz. Then here 100 volt is the peak, so I am converting into RMS. Then here change it to 0.005. So I am not going to do any step up or step down in the transformer, so I am using the same parameters. So the transformer is ready. Now we need diodes. So for that, go to Sim Power Systems, Specialized Technology, Power Electronics. So in that we can get diode. So diode I have selected. So double click it. Here snubber. So what we can do here, I am not going to use snubber. So I am giving it as, I am giving high values. Measurement output is also not required, so I have disabled it. So connect at the output of the transformer. So I am renaming it as D1. then control left click drag to make another copy D2. So then connect these two. Now we need a capacitor and R load. So for that go to elements. So in that RL series RLC branch. So drag and drop it in the model page. Control R to rotate. So double click it. So RLC. Here I am going to use 100 microfarad. So renaming it as C. So then control left click drag to make another copy. I'm renaming it as R. This is the load. So double click it. I'm going to use 10 ohms. So this one, let it be 1 microfarad. So I have connected. So R and C at this terminal and the mid point of these two windings transformer. So then the circuit is ready. Now we need to do two things before running this model, executing this model. So first we have to give pulse for these switches. So for that, in Simulink sources, so here we can get pulse generator, drag and drop it. So I am renaming it as P1, pulse 1. So double click it. So period we have to give in seconds. So I'm going to consider for one cycle, that is 360 degree. In terms of time, it is 0.02 seconds. So for first switch and the second switch, there is no delay. So pulse 2, drag and drop it, make another copy, and I have connected it. Then control left click drag 3. So here, so it should first half of the AC waveform 1 and 2 will be switched on. In the second half of the first cycle, the 3 and 4 will be switched on. So that is 180 into 0.02 divided by 360. So I have given a delay. So control left click drag to make another copy, connect this. So now the pulses are connected. So now go to SimPower Systems measurements. So voltage measurement. I'm going to measure input voltage as well as the output voltage. So this one I'm renaming it as V in. So then we need to measure the output voltage. So here I'm measuring across the load. This one I am renaming it as V out. So as per this circuit, the V out will be 1.5 times the input voltage V in. So go to Simulink commonly used blocks. I'm selecting mux. So I'm going to plot both the voltages in one scope, in one window. So I'm using a mux. So we need scope. So drag and drop it, connect it to the mux output. So double click this. scope, settings, history, remove this data points to last, click OK, close this. Yes, now the circuit is ready. So we need to place power GUI. For that, Simscape, SimPower Systems, specialized technology, there we can get power GUI. So drag and drop it in the model page, double click it, configure parameters, change it to discrete, click OK, click OK. Yes. So now we can simulate this. So I am going to simulate the circuit, run, press run. Here now the input voltage is 100, so we should get a 150 voltage at the output. Yes. So input voltage is this 100 and the output is 150. Now I am changing the input by 50 volt. So we should get a voltage of 75 at the output. Yes, I am getting 75 volt at the output. So here this is in boost mode. You can change this circuit topology for a buck mode also. And I have used the ideal switch. So as per your requirement, as per the application, we have to choose MOSFET or IGBT. So I have explained about the simulation of DC-DC converter, simple circuit topology in MATLAB. So thank you for watching. Thank you.